Okay, anatomy students, welcome to our second video that we've ever done here. This is our first video for our new bone unit. As you can see, this is a unit on the cranial bones. Our objective, hopefully at the end of this video, you'll be able to correctly identify all 8 cranial bones. There are 8 that we need to know, so well, that's a really nice and straight line there. 8 that we need to know out of the 206 bones in the body. So, hey, after today you'll have less than 200 to go. Great. Let's get started. First bone, let's get rid of those. First bone that we want to take a look at is the frontal bone. It's highlighted here. We see the frontal bone also on the front. It's also known as your forehead. Frontal bone, top of your orbits, top of your eye sockets, right where your eyebrows would be. It contains sinuses, some of those sinus headaches you feel. First feature that we need to notice is the coronal suture. Do you see this zigzaggy line right along the top of the skull? When you think of corona, I'm hoping you think of, that's right, an eclipse and the corona going around the sun, I'm sure. That's what we think. It's like a crown going on the top. So we have the coronal suture that connects the frontal bone to the parietal bone, which is the bone right behind it. And there's this little zigzaggy line where the bones have actually grown to each other. Now in infants, when they're born, you've heard of soft spots. It happens because the bones of a baby's head have not fused together yet. They haven't grown all the way. It's due to that way that the bones in your head form. It's not endochondral ossification, but intramembranous ossification, where a membrane that surrounded the brain turns into bone, and we get those soft spots or fontanelles. So we have the coronal suture. Another feature that we want to be able to notice on our frontal bone is the supraorbital foramen. So if orbital is eye, supra must be above the eye, and we see one supraorbital foramen there and another one right there. They're like little holes that you will see on the frontal bone that blood vessels and nerves pass through. Alrighty, so frontal bone, we need to know the coronal suture and supraorbital foramen. Moving on next to the parietal bones. Again, what was this suture? It's called the coronal suture. So for the parietal bones, these are going to form the sides of your head. So either side, top of your skull here. Sagittal suture is what's connecting these two together. Now you should be able to think to yourself, what must be meant by sagittal suture? It's a certain plane that goes through our body. As we look here, this is a top view. Here's our frontal bone. Here is a sagittal, there's a sagittal suture right there, and here's a parietal, and here's a parietal bone. So we're looking right at the top view. You can see how it's all crazy, squirrely in between here, and kind of locking these two together. In class, you'll see that these bones do not come apart. They are pretty well fused together with these sutures. You're in luck. The parietal bones, there are no other features you need to know, just the suture, the sagittal suture. There are 2 parietal bones. Moving on to the temporal bones. Temporal kind of sounds like your temple. This would be the side of your head. You see this weird shaped bone. Okay, temporal bone has a lot of features. So there's 2 of them, one on either side. The first feature, we'll start with the suture. It's called the squamous suture. Oops, let me go back. Squamous suture, and it comes right along here on the side. On both sides we have a squamous suture. So let's keep going. If you look here on our side view, again you can see the squamous suture right here. They're taking it. There's the bone by himself. You see lots of weird things. I see a bump down here, a little needle part there, and a little bridge going off to someplace. So let's take a look at these. First one is the zygomatic process. Zygomatic process is this little projection sticking forward. It's called the zygomatic process because there's another bone. In fact, this bone right here is called the zygomatic bone. The zygomatic bone touches the temporal bone, and the temporal bone touches the zygomatic. So the temporal bone has a zygomatic process. What would the process be on the zygomatic bone that touches the temporal bone? It's called the temporal process. We move on now to the mandibular fossa. Mandible is this jaw, and the fossa, as we know, are depressions. You can see it right here. It's right by the ear. It's this depression that you're seeing here. It's part of the reason why when we yawn, it sometimes pops our ears. You can hear this kind of popping that goes on when we yawn. Okay. We next start with the auditory meatus. And meatus is more than a foramen. It's like a tunnel. All right, we can see it labeled there, so this would be where our ear canal would go in there. Okay, so we have the auditory meatus. You can actually see him coming out on the other side because this is the inside view of the same bone. You can see the internal auditory meatus and the external auditory meatus. Moving on to the mastoid process. When I see the word mastoid, I want to think massive. And that is this big old one right here at the very bottom. This is what's actually going to be connecting your neck muscles. This big, huge muscle that comes down your throat that you use to find your pulse, called the sternocleidomastoid. It's connected to the mastoid process. It allows us to move our head around. Big, huge muscle connects to this big bump on the temporal bone, the mastoid process. Our next point is this little knife point. It's called the styloid process. Now when I think of styloid process, I think of stiletto heels. Think of those little pinpoint heels. We can see this little pinpoint thing. It's called the styloid process. It's an attachment point, again, for muscles that control actually your voice box. As you lift up your larynx up and down, muscles are attached to the styloid process. All right? So again, this is the temporal bones. Moving on now to the occipital bone. Only one of them. You see it's on the back of your head. Back of your head. The features that we're going to take a look at here. First is the suture again. It's lambdoid suture. Now you might be wondering, lambdoid, does it have something to do with sheep? It has more to do with this letter called lambda. If we look at what the lambdoid suture looks like, you might notice it kind of has that same shape. Or maybe it's, for some of you guys, it looks like a Mercedes logo here. Almost could be a peace sign. There we go. All right. So we have the lambdoid suture. That's what connects it to what would these bones be here on either side. Hopefully we know. Give you a hint. Parietal with a big P. We then take a look at our features. The first one is the foramen magnum. When I see magnum, I think big again, and that is a big hole. If I flip this bone upside down, you see a gigantic hole right there. Any guesses what goes through the hole? Be your brainstem connecting to the rest of your spine, the foramen magnum. We then have the external occipital protuberance, or if you want to be cool, you can call it the EOP. That is this bump right here at the back of your head. In fact, if you feel on your head right now, you'll be able to feel a bump right back there. Okay, and muscles connect from your neck all the way to this thing. So when you put your head up, muscles are pulling on your EOP. There's a famous external occipital protuberance. You maybe have seen this character right there. And cute Pluto has this gigantic bump on the back of his head. Your dog, if you ever scratched your dog between the ears, you might feel that bump. So it's a big bump on the back of your head, the external occipital protuberance. You can see it down there on that one as well. Here it is as well on that model there. Our last one are the occipital condyles. A condyle, as we know, is a smooth, rounded projection that's going to allow two bones to articulate. And in this case, let me get rid of some of those lines. This guy is going to articulate with the vertebrae, the very first vertebra on your spine. It actually allows your head to go up and down. We say yes motion. The condyles are actually rubbing on the first vertebra, C1. We'll learn more about them later on. Again, these are the occipital bones. Let's move on. Next we have the sphenoid bone. Very funky word. Sphenoid, you can see its location. He's pretty much in the center. The sphenoid bone actually touches every single other cranial bone. Again, by being a cranial bone, that means these bones form the skull cavity that holds our brain. And the sphenoid bone is kind of like the keystone bone. It touches every other bone in the skull. I mean, of the cranium at least. It doesn't touch the mandible. Alright, in the sphenoid bone, the cool thing that we need to know is there's something called the sella turcica, which literally translates into turkey saddle, and it has nothing to do with turkeys. This is this special little room for a very important gland that we've studied a lot in our last unit called the pituitary gland. This is a little home for the pituitary. So if we take a look, this little spot right here, the pituitary gland is going to sit right in there. Alrighty? It's like the most protected place in your body pretty much. You're inside the skull already, and at the center of the skull in this little room is where the pituitary is going to sit. You can take a look. If you pulled the sphenoid bone out of the skull, it kind of looks like a little bat wing kind of situation going on here. And you can kind of see the outline. Notice the bones it touches. It touches this bone, the blue one. We know it's hopefully, we know it's frontal. It touches this green one on both sides. That's the parietal, I hope we know. Touches these pink ones, which we know are called the temporal, and the blue one that we just covered right here, which is the occipital. Hopefully you can finish it. And then there's only one more bone to look at, and it's this little gray one right there, right in the very middle of the skull. So let's take a look at that one next. Alright, the last bone that we need to learn is called the ethmoid bone. Ethmoid bone, we got a nice arrow pointing them out. Here's our side view. We should hopefully be able to recognize all these other bones. You can see a nice great view here of that turkey saddle. Right there, the sella turcica, and right there is where the pituitary would just chill out in that little saddle. Alright, so let's take a look at some features of the ethmoid bone. First is the crista galli. If you ever wondered how the brain sits in the skull without just like floating and banging around on the walls, the brain is actually anchored to this little sail right here called the crista galli. Let's circle him in green, make him show up. So that's called the crista galli right there, and it's this little sail that anchors the brain like a membrane, wraps around the whole brain, surrounds it completely, and is anchored here. When we get to the cat dissection and you try to remove your cat brain to see the pituitary, you're going to need to break this attachment point here, okay? It's kind of a good important place in your brain, okay? Kind of anchored up there at the front. Another feature is something called the cribriform plate. Now we're going to see that guy nearby here. It's going to be on the side. He has all the little holes. Got better images to show you here in a moment about the cribriform plate. A lot of your olfactory, got little nerves for your sense of smell and stuff is going to be traveling kind of through that. Lots of little small holes. You'll see that easily in our class. We next have the perpendicular plate. Perpendicular plate, if I get rid of these other lines, it's what makes up this vertical part of the nose. In fact, where the word ethmoid is written, you can actually see where the word ethmoid is written. This is the perpendicular plate. It's going up and down. It's perpendicular to the horizon. Okay. Next we have nasal conchae, or turbinates. These are really important for helping you both warm the air that you breathe in as well as help filter. If you guys have ever been in the snow and you take a big deep breath of cold air and your mouth is open, you can actually feel your lungs get cold. Whereas if you breathe through your nose, the nasal conchae help actually warm the air on its way in. Plus, it's got this increased surface area that helps swirl the air and help you filter out the dust to make boogers, basically. So, take a look. Here's the crista galli. Here's a nice view of it right here. Ethmoid bone. I see the cribriform plate right there on the sides. I see the perpendicular plate vertical here. Here's another view of it, kind of a colored version. As again, cribriform plate right here along the side. This blue area is actually cartilage. We'll learn about that with the facial bones in the next lesson. But you can see part of making up this nasal septum. Do we see these weird... Oh, let me go back. Do we see these weird little bulbs on the side? These are those nasal conchae, the things that are going to help swirl the air inside your nose as you breathe in and kind of warm it and help filter it. All right, that finishes all of the bones. Let's do a little bit of review. So you're going to want to pause if you need to, maybe take a piece of paper out. Go ahead, let's write down the question. Which cranial bone touches every other cranial bone? You can pause, think of your answer. If you wrote down sphenoid bone, you got it right. Let's go to question number 2. Take the time, write it down. What keeps the brain from freely moving around in the cranial cavity? Hit pause. Your answer: a membrane surrounds the brain and anchors it to the crista galli on the ethmoid bone. Last question. Why are infants born with soft spots on their skull, and how do cranial bones form? Go ahead and hit pause. Write down your answer. Newborns lack sutures because the individual cranial bones haven't grown together. Cranial bones form through intramembranous ossification. Alright, that does it. We'll look forward to seeing you guys in class, and you guys get more chance to do some hands-on practice identifying these bones. Great job.